Hello! Today we're going to take a look at the last section in our topic, which is 2.4, applying the properties of angles to solve for unknowns. So exciting! Alright, so what we're going to do is we're actually not going to learn anything new, but we're going to combine the skills we already have together. One of those two skills that we have is to identify angle relationships and know whether they're equal, perhaps supplementary, or some other property that exists. And we're going to also combine the skill of algebra and solving equations. For each of the examples that we're going to take a look at, be careful to read the instruction because sometimes, usually, tells us to make sure we identify the relationship. So we want to indicate what relationship we are using. Then we're solving for the unknowns. Sometimes, not always, but sometimes there's also that extension to also solve for those indicated angles. So something to just keep in mind here. So we are going to get started. If you feel like you could try these on your own, you are welcome to start. Just go ahead, pause the video, try them out, and then resume the video when you think you've got it. All right, I'm going to jump right in. These two angles here, this one at the top and this one at the bottom, since my lines are parallel, are considered to be alternate interior angles of parallel lines. Alternate exterior angles of parallel lines. We know that alternate exterior angles of parallel lines are equal to each other, so I'm going to set those two expressions equal to each other. Okay. I'm going to go ahead and I'm going to rearrange to isolate for x, and I'm going to solve for that unknown. So I'm choosing to move my x's to the right, which means I have to move my constants to the left. So I get 24 is equal to 3x. I divide both sides by 3 to isolate for that x value, and I get x is equal to 8. Note that x is part of my my angle value, so I do need to make sure I'm including the angle measure of degrees. But here's my final answer. I've indicated the relationship I'm using, and I'm also solving for that unknown. Now, just for fun, for this first one, I could in fact go ahead and use this value to make sure that I get those angle measures. And I could go ahead and do that by plugging it in here. So let's say I had 3 instead of x. I have 8 degrees plus 10 degrees. That's 24 degrees plus 10 degrees, which is 34 degrees. In the bottom, same thing. I can plug in an 8 degrees for my x. And I could do that math. That's 48 degrees minus 14 degrees, which is 34 degrees. Now, these two values are equal, which I anticipated, and that just indicates that I've done the solving correctly. Okay? So just because they match doesn't mean they're necessarily right. I could, in theory, have gotten the wrong angle property and had them match, but they're actually supposed to be supplementary, and that could be wrong. But if they do match, it usually indicates that you did at least the algebra portion correctly. So that's nice. All right, that pink part we just did, solving for those indicated angles, wasn't actually necessary. It didn't say to do that in the question, but just know that sometimes the questions could ask for those pieces. All right, example 2 here. Again, like I said, pause the video if you feel like you can do it on your own. Resume it when you're ready. I'm going to jump in. All right, what I'm noticing is that the angle formed between the red and the black line is vertically opposite from this angle formed between the red and the black line. Now, this angle up here is technically made up of two smaller angles, the 65 degrees and the x. But I could still say that there's some vertically opposite properties going on. And that's what I'm going to do. So the angle relationship that I'm going to use is vertically opposite angles. And that means my angle 7.5x is equal to the other two angles, 65 degrees, and x added together. Because remember, when we were talking about it, we mentioned highlighting lines at the beginning of the unit there, so that we could see what angles are related to each other. So that's how I know it's not 7.5 is just equal to 65. 7.5x is not equal to 65, but the combination of 65 and x. All right, and then we're going to do some math. I'm going to subtract x from both sides. I get 6.5x is equal to 65 degrees. And I'm going to divide both sides by 6.5. And I get x is equal to 10 degrees. I can now go ahead and use that x value to solve for the indicated angles. I don't have to because the question didn't ask for it, but just know that I could. All right, the third example here, the angle relationship that I see is that I have non-adjacent interior angles. So those two interior angles, R and B, will sum to give me that exterior angle, angle JEB. So I know the exterior angle is equal to the angle sum of the two interior angles. And I'm going to set it up accordingly. Now I could collect my like terms before I move things over, so I'll get 96 plus 9x, and then go ahead and do that algebra accordingly. Minus 96, minus 96, that gives me 36 degrees. I guess I should have added degree signs here. Let me backtrack. There we go. Now we're good. 36 is equal to 9x, divided by 9, and we have x is equal to 4 degrees. All right, last but not least, this one here. We have three angles, and all three of those angles together form a straight line. So these are all considered to be supplementary. When I'm talking about angles here, note I don't have one angle equal to another anymore, or two angles equal to another. I have just three angles. I don't need a bracket here, but I could. I'm going to add my bracket here just for the sake of making it obvious. But I know those three angles add to give me 180 degrees if they're supplementary. The brackets don't, in fact, make a difference, so I could get rid of them. It doesn't change things. But I'm going to continue solving. I'm going to collect my like terms on my left-hand side. X plus x plus x gives me 3x. 10 plus 20 gives me 30. And of course, I'm going to have those degree signs in there. Essentially, include degree signs on everything, except I don't need a degree sign where there's an x, because I know that eventually my final answer already indicates that degree sign should be there. All right, I am subtracting 30 from both sides. I get 3x is equal to 150 degrees. Divide by both sides by 3. And I get x is equal to 50 degrees. So, a couple of things to keep in mind. We can see the combination of our angle properties in algebra in really any aspect of this unit. I could have had a five-sided shape, a pentagon, and said x, 3x, 2x, x plus 4, and 7 degrees. And said, hey, what about this? How can I solve for it? And you would have said, oh, a pentagon is a five-sided shape. There's actually 3 triangles in a five-sided shape, or 5 minus 2. And to find what all of these angles would equal up to, well, that's easy. I would just multiply 3 by 180. And when I get 540, I know that all of those angles would add up to give me 540 degrees, and I could solve for x no problem. So I could use it with my polygons. I can use it with my triangles, and that we kind of already knew. But that triangle property here, that's something else we learned in that triangle section. So I'm welcome to use it there. I'm also welcome to use it with anything with parallel lines. As long as I have parallel lines, I know that my certain angle properties will have equal angle pairs. And then I could use it with just general line relations, or general angle relations, like my vertically opposite angles and my supplementary angles. So this skill can be inserted into any segment of our unit because it can connect to anything where there's relationships involved. All right, that is it for now. Have a wonderful day and see you soon.